The Vigene cipher improves on simpler substitution ciphers by using multiple shifts rather than just one. So in a shift cipher, every letter is shifted by the same amount. In the Vigene cipher, the shift depends on the position of the letter. And so we choose a keyword, convert it to letters, so convert its letters into numbers, and then repeat those numbers as needed. So if the keyword has length L, so if your keyword has length L, we just repeat this as needed. And so I think the easiest way is to actually just show an example here. So let's say we want to encrypt the plain text attack at dawn, right? And the keyword is lemon. And so this is the secret keyword that needs to be, or that needs to be shared between the person who wants to decode, right? The encoder and the decoder. And so how does this work? So first, take your message, attack at dawn, convert it into the numbers, right? So you had an assignment, every letter, so A was 0, B was 1, and so on. Convert it into numbers. Take your keyword. Now what you do is you write your keyword, and then when you're done with it, you repeat it. And then when you're done with it, you start again from the beginning. So the person who is decoding, they know that you write out like lemon and then lemon again, and you continue to write that as many times as needed. Now these, you then convert into numbers. And now you just do the sum of these two, mod 26, and then this is your ciphertext, right? So attack at dawn becomes this over here. And so one way to think about it is that the Vigene cipher is like applying different Caesar shifts to different positions in the message. And so this makes simple frequency analysis much harder than before, because the same plaintext letter can be encrypted differently in different positions, right? So you see that, for example, the letter A here becomes an L, but when the letter A appears again, it's now an O. When the letter A appears again, it's a letter E. When the letter A appears here again, it's a letter N. So it's not as easy to do frequency analysis on this, like simple frequency analysis, right? However, the fact that this is repeating is actually the weakness of this system. And one classical attack is called the Kaczynski examination. And the idea is to look for repeated blocks of letters in the cipher's text. And so the distances between these repeated blocks are often going to give some information about the keyword length. And so there's going to be a longer example of this attack included in the slides. So go to the slides and we show a nice example of it. Also, if you go to the references, there's a nice book that we suggest on this. But we're not going to record this as part of the main lecture. So the main takeaway for this is that the fact that you're using this repeatedly is going to create patterns. And so a natural question then is, what if you never repeat this? And this is actually going to lead us to something called the one-time pad.